I've been responsible for 2 books, and to introduce this talk, let me just say what were the issues that were left unresolved in those books. And so the first book, A Farewell to Arms, was about the static Malthusian world before 1800 and the fact that it seemed to have an unexpected dynamic, which was one of survival of the richest and the takeover, at least in England, of the pre-industrial population by descendants of those who were economically successful. And you can see this very clearly for people dying 1500 to 1780, where these are just people with asset income. So this is the top quarter of the population. But those with the highest level, the highest decile, had more than 4 surviving children per generation. Those at the lowest decile here had barely 2 surviving children. And for the society as a whole, the number of surviving children is around 2. And so it meant that this kind of upper class was increasing its share of the population generation by generation over centuries. And this process effectively came to an end in England with marriages around about 1780, when this gradient flattened, and then this gradient turned negative. Right? And so we get these very different demographic regimes. And then this is just, again, illustrating, if we even take amongst the wealthy the top tercile, you can see that this differential in fertility is actually greater when we go further into the past. And it's evident in data in England all the way to when records begin in about 1250. And so it turns out that after the book came out, Cameron Campbell and James Lee, who are both very fine demographers of China, found very similar processes operating in Chinese lineage that they were able to study, where again, the more successful members over the course of 6 generations have many more descendants. And it's also been observed in pre-industrial Sweden and also in Flanders. And so it seems to be a very general phenomena of settled agrarian societies is this kind of survival of the richest. It's not found everywhere though. In Quebec, there was instead a process of survival of the poorest. And there's also some evidence maybe in America of similar kind of frontier societies which were much wealthier, even for the poorest people, actually experiencing a different regime. And interestingly, the Quebecois who emigrated to the US are the only white underclass now in the United States. And they did actually, as I say, experience these somewhat different pre-industrial demographic regimes. And in England, these changes are associated with a dramatic decline in interest rates. 10% now, if a hedge fund can get you that money, you would want to go for it. This was available to any investor in England in 1200 or 1300. And by 1800, interest rates had declined to 4 or 5%. There was a significant decline in the levels of violence, ordinary violence in the society. There's a huge increase in educational attainment and a modest increase in work hours. And so you do see these interesting behavioral changes in the society where overall living standards are actually not changing over this period. And so the unanswered question of this book was, do demographic regimes have lasting impact on the economic capabilities of populations? And are those impacts largely cultural or are they genetic? Now, the next book, The Sun Also Rises, is focused then on the intergenerational transmission of social status and had this idea of using surnames as a way of tracking people over many, many generations. And it has this kind of very interesting result, which is, I'm afraid a lot of people who study modern social mobility don't like, which is that in the long run, there's a very high intergenerational correlation of social status. That there's always regression to the mean, but that process takes, for those who are at the extremes, 10 to 15 generations. And there's really very strong persistence in status. But the other surprising thing is it doesn't seem to vary much across societies. You can observe the same phenomena in modern day Sweden as in medieval England, with roughly the same rates of social mobility. There was no improvement with the Industrial Revolution. There was no improvement with the spread of universal schooling. There's been no improvement in England. The current rate of kind of long-run social mobility is roughly this 0.7 to 0.8. And so that was the first kind of interesting finding. And again, the question was going to be, well, what drives this? And one of the interesting things is that in writing this book, when I worked on this book, I knew essentially nothing about genetics. And all we wanted to do was to formulate a model that would describe this process. And it turns out that this parsimonious model seems to work very, very well. And that's where there's a kind of a social phenotype that we observe for people, but there's an underlying social status genotype that they carry. This status genotype is being very strongly transmitted, as I say, with this intergenerational correlation of 0.7 or 0.8 across generations. But what happens with the phenotype is that depending on how big this error component, this random component is, you can observe very different short-run rates of social mobility. So for something like longevity, you'll find that the intergenerational correlation is only something like 0.1 or 0.15. For occupational status, it's 0.65. And so what you're actually getting in this world then is this underlying slow transmission, and then this gets translated into an observed world where you can have variable rates of social status transmission for different aspects of people. And so that actually seemed to be a model that successfully described this world, but it still left this question, what is it that's actually doing this transmission? And can you actually significantly change these rates of transmission by any kind of intervention? And so now I've embarked on writing a third book, and this is going to be based around a data set that I'm busy constructing along with my now major collaborator, Neil Cummins at LSE. And so everything after here, it's not me, it's Neil Cummins who's responsible. And so currently we have a lineage of about 277,000 people observed in England from 1750 to 2018, where we can link about 90% of people to their, in any generation, to their parents. And so we're able to observe then people across 6 or 7 generations for many of these people. And we deliberately oversampled very rich and very poor people. But then we've got a lot of people in the middle, and we actually hope to increase that. We've still got data coming in to maybe 350 to 400,000, right? And it's also based on public data, this information. And so the nice thing is we use people with rare surnames in order to have much higher rates of linkage. But it also means that it's relatively easy to link them to other sources of records that should become available because of the rarity of the surnames. And a sample of the database looks like this. This is just for one particular family. The thing that we're able to do is effectively to crowdsource a lot of this because of the intense interest in genealogy. There are many families for which actually very good genealogies are available, right? And genealogies that reference the sources so that you can start with that and go through and check and then use that as a skeleton. And then what we need to often do is add social status information, but they actually link to the sources that give this information. And so sources like Ancestry actually are very useful here in terms of this. And then it turns out, I love the English, they're so eccentric. It turns out that there's an organization in England, the Guild of One-Name Studies, where its 2,733 members take an oath to follow the history of the name that they adopt wherever it goes. And so, and they have annual meetings, they have a journal, the Journal of One-Name Studies. I've published in the Journal of One-Name Studies. And we were able then to contact members of this guild, and from some of them we got amazingly high quality data. There's one name, Argyle, that one man had spent 25 years researching and sent us like a 20 megabyte file where he had checked the Argyles across every continent and across every documentary source that he could find. And so, as I say, some of this, now some of it is not quite of such good quality, but some of it is amazingly good quality. And what's actually kind of sad is that a lot of this was going to die out as these people get older, but it is this incredible collective repository of information. And what are the social outcomes we can get for people? Everyone in England after 1858, we can get their wealth at death if they die in England. We have adult occupations from the censuses and the 1939 population survey. We have schooling ages somewhere between 11 and 20, if people are observed in the census or here. We can tell for a lot of people if they have professional qualifications. We have a complete list of people who went to Oxford and Cambridge. We have partial lists for other universities. We know their lifespan if they were born before 1920. We know where they were born, where they married, and where they died. If they're still alive in 1999 and they're an adult, we can actually estimate their house value because we get their address from the electoral register. There was a complete register published in 1999. And then if we had sufficient funding, birth certificates from here to 2018 show parent occupations. Marriage certificates show the occupations of the parties and of their fathers. And death certificates show occupation and cause of death. And so we're hoping to pool a selective group of people where we can actually link occupations over something like 6 generations. And so and as I say, this is a huge kind of ongoing effort. We've only very partially done this. The data so far means we have lifespan for 111,000, we have wealth at death for about 42,000, 32,000 higher education for males. Women before 1920 have no formal educational status. But what we'll see, interestingly, is the data seems to suggest that there's been no change in assortative mating with the actual acquisition of women of formal educational status, because assortative mating seems to be very tight, even in this period when there is no formal education for women. And then we have occupations, we know if you're at work, we know places of death, we know complete fertility, we know house value. That will expand enormously once we keep adding on data. And then the other nice thing about the database is when these people emigrate, about 6% of every cohort actually leave England and Wales. We can actually follow them as migrants to the major locations of Australia, New Zealand, Canada, and the US. And in places like Australia, you can get from their electoral registers occupations up till 1983. And so we can actually, and we try everywhere just to keep on following people. And remember, the Guild of One Name Studies, that's their oath, right? They, by the way, are in opposition to the Guild of One Place Studies, which does exist, which has a different principle of thinking about the world, where they're only interested in events that happen in one place. And we don't like the one place studies, we like the one name. And here, in an amazing kind of piece of serendipity, what we are actually going to do in trying to estimate, so what we want to use this data for is to say, can we use this to estimate the importance of genetic transmission of social status attributes? And it turns out that the paper we rely upon there is R.A. Fisher's 1918 paper published in the Transactions of the Royal Society of Edinburgh. So this is the 100th anniversary of the publication of this incredibly insightful paper that we actually are relying on here in terms of the paper. And when we initially looked at this, the assumptions of the Fisher model seemed very severe. And in particular, the genes and environment are uncorrelated, or the environment has little independent impact on outcomes. And so, as I say, this was just an exploration of, well, what would this model say? And will we see very clearly that we're going to violate these conditions? And as I say, the Fisher model then gives predictions for the correlation of any two people in the lineage. And it turns out the prediction, it depends on whether the matching in marriage is on the genotype or the phenotype. And what I'm going to show you here is our data suggests that there is matching on the genotype, not on the phenotype, right? Surprisingly. And so this is the one we should concentrate on. And you can see that there are only two things that matter then. There's the hereditability of the trait, And then there's the correlation genetic and the relevant genetics of the partners in marriage, right? And those are the only two things that influence the correlation. If it's matching on the phenotype, then you have to look at both the phenotype correlation and the presumed lower rate of genotype correlation here, okay? But as I say, what we'll find is that this actually seems to fit the data better, okay? And what's going to happen in this model then is that long-run social mobility depends only on this number, 1 plus m over 2. If there's random assortment, then it's going to be a half. If there's going to be this long-run correlation we observe of 0.8, then there has to be an assortment at level 0.6 correlation in the relevant genetics of people in marriage. And so when we initially did this, we thought, well, we're out of the game here. There must be something else operating because it's not going to be possible to have that kind of degree of assortment in marriage. And that's what other people told us as well, which is that it's just not feasible to get that kind of level of assortment, okay? It turns out that that additive genetic model has exactly the same formal structure as the model in The Sun Also Rises. So it turns out they are just formally the same model in terms of looking at intergenerational correlations. And so it turns out the stuff that describes the data is actually going to be the same here. And in particular, social mobility is a first-order Markov process. Older generations and collateral relatives will actually play no causal role, but they will provide information about the likely outcomes. And so that's something we can actually test using the lineage, is do relatives play, other than the parents, play any particular causal role in terms of the transmission, right? And so it turns out we can get lots of kind of interesting potential tests. Now, what we did want to do is say, well, look, if we're going to have this kind of genetic model of transmission, it would be nice if we had an alternative cultural model that we could actually kind of have a competition between the two. And it's quite difficult to specify a cultural model of transmission because it's really a very loose kind of idea. But at least so far, here's an idea that we think should operate in the cultural model. So sibling correlation should exceed those of the parent-child. Let me just take an example. So it turns out in my own family, I grew up as one of 4 children. I had this identical social environment as my siblings, right? Same expectations, same environment, stuff like that. My parents, it turns out, both came from families of 12, which were each dysfunctional in its own way. On my mother's side, her father was an alcoholic. On my father's side, his father had a belief that all education was a waste of time. And so he barely made it through high school and was lucky enough to go to college, right? And so their environment would be very different from our environment, and myself and my siblings shared this. And it turns out that if you're going to have a cultural model with regression to the mean, and it's going to depend on the family environment, then it's got to be that between generations, the family environment is regressing to the mean. And so that there'll be more dissimilarity between environments across generations than there is between people who fall within the same generation. And so that's the idea. And so we can actually specify a cultural model then where the phenotype here depends on the family environment plus some random component. The family environment is regressing to the mean across generations. And that's just a very kind of simple cultural model. But it produces different implications, because now what's going to happen is the parent-child correlation will be that rate of regression to the mean of the family environment that's multiplied by some attenuating factor, whereas the sibling correlation will be just based on this attenuating factor caused by this kind of random component. And so you will actually get, and this is different from the predictions of the Fisher model. The Fisher model with assortative genetic mating, the prediction is the parent-child correlation will be the same as the sibling correlation. And so we actually would get a different set of correlations with these different models. And so the pattern of correlations in this kind of cultural model would then, it's possible to lay out with this model all of the pattern of correlations. And as I say, these will differ from the Fisher correlations. And in particular, the parent-child correlation should be the same as the aunt and uncle in the cultural model. But in the Fisher model, the uncle and aunt correlation will be lower than the parent-child correlation, right? And so we can actually potentially test this. And then a model of additive genetic transmission that you all know of course, is height inheritance. And one of the other things you observe in this process is a linearity here, right? The same rate of regression to the mean from above and below. And so another sign of some kind of cultural process would be to not have that linearity, right? And so if it's really controlled by many hundreds of genes and it's measured in some way that it's normal distribution, then you expect this symmetry, and a sign of failure would be if somehow people are sticking at the top or sticking at the bottom or showing some distinct nonlinearity in the process. And so it's another thing we could impose in terms of testing this. And so this is a bunch of height correlations for Norwegians, who are all, of course, enormously tall. And then what we can see is that you're going to get this pattern here where if we put the log, there should be the log of the height correlation here, and then the genetic distance here, then you'll get this linearity. And when we do that, we can estimate 1 plus m over 2. It comes out to be 0.55. That's consistent with the fact that people don't match very strongly on height. The correlation on height of partners is only something like 0.15. And so you get relatively rapid regression to the mean of people with unusual heights. And you can see that the R-squared, this is the weighted set of regression, the R-squared is 0.93. Now, what data do we have so far on people by relationship? It turns out we have a lot. We have 58,000 fifth cousins and 71,000 fourth cousins, right? Now, not all of these yet with status information, but hopefully in the long run with a huge amount more of this status information. And so this is on, for example, on higher education, wealth at death, we're getting now kind of significant numbers of observations across people quite far apart here. And the important thing here is no one actually knows their fifth cousins, right? I have, as a result of my parents, I have 44 first cousins, almost none of whom I could recognize in the street, right? And so actually you're talking about people here who are likely to have very limited social interactions. And then one of the first things we can say is, well, what about son occupational status relative to father's status? You observe here this kind of very nice linearity, right? So this is the log of status because in our status measure, occupational status, it's very skewed at the upper end. And so we take the log to kind of make it into a more normal distribution. And what you'll see is that it looks very much like there's symmetry in the top and the bottom of the distribution and this kind of movement to the mean in a very smooth fashion. And even for wealth relative to log father's wealth by decile of the father distribution, it's not quite as smooth here, but it's again pretty linear, right? And so it looks as we would hope for with the Fisher model. And then we have all of the individual correlations here so far. And what's interesting is in our data, fifth cousins are all statistically, this is the standard error of the correlation, they're all statistically linked still in our data, right? And so that there is actually this amazing linkage. There are all these people out there in the world that you have some statistical kind of linkage to that you have never met, but you're correlated with. And so here's the first kind of interesting piece of information. What about fathers and sons versus brothers? And these are various different measures of social status, or things linked to social status. And as I say, what is very nice here is the father-son correlation and the brother correlations are essentially identical in this data, right? And that, as I say, is something that's very unexpected on kind of cultural models of transmission. Why is there so much variation among siblings? But of course, it's built into genetic transmission, right? And it's actually, as I say, a very nice feature of this data. And so lifespan, for example, is very low correlation father-son, very low correlation brothers, right? Occupational status, very high correlation here, very high correlation here. And so as I say, this is something that's quite, I think, unexpected on a kind of a cultural, purely cultural model or largely cultural model of transmission. And then, on the other hand, if we take the father-son versus the uncle-nephew correlations, you can see that they all fall off this line, right? That basically the father-son correlations are much stronger than the uncle-nephew correlations, whereas we were expecting on that simple model that I did of cultural transmission, that those should actually fall on the same line. What would be very interesting, if anyone has ideas about, well, are there better models of cultural transmission, right? But now you know that some of the things that you would have to produce in such a model, right? You'd have to have some mechanism that would actually cause the father-son and the sibling correlations to actually be the same, right? There would have to be something, and it's very hard to think about in cultural transmission, what would be embedded in cultural transmission that would produce that kind of symmetry. And then if we take wealth, log of wealth correlations and genetic distance, you can see that this fits pretty well. And so the R squared of the fit is about 0.91. And then the calculated long-run intergenerational correlation here is 0.81. And so wealth is very, very persistent within these lineages. And as I say, the fit is very good here. I mean, these things are falling pretty close to a line. And remember, there's various measurement errors because sometimes we won't have correctly linked the fourth cousin, right? And so there'll be linkages, and then there's errors in the measurement of wealth. And then the other thing is that these are measured across different time periods, right? And so we have these normalized, we normalize it by average wealth in each period, but there could be changes in this measure that we're capturing. And then occupational status, the correlation is not as strong here. The R squared is lower. It turns out for some of these, we still have very small amounts of data because this is your great-great-great-great-grandfather's occupation relative to your occupation 150 years later. And so some of that is a little bit difficult to measure, right? But what's amazing is that the slope of the line is very, very similar, right? And so the other thing that seems to come out of this data is some idea that there's a kind of almost unitary social status that people have, right? It's all regressing to the mean at similar rates, even though wealth is very different. I mean, it's transmitted actually in different ways, but you've still got to decide whether to spend the money you get or not, right? And so what's interesting is that the different aspects of status seem to be kind of clustering together. And then this is, did you attain, this is a 1-0 variable, did you attain higher educational qualification? And here, as I say, the R squared really becomes quite low, but the underlying slope is actually still very similar, right? And so here the data is speaking very clearly, and it's very consistent with the surname evidence, that this is based on completely different evidence than the surnames, but it's saying that there is this incredible degree of persistence within these lineages and very similar across different attributes. So the problem that confronted us, so I presented this preliminary stuff a couple of years ago, and people said, well, this is very interesting, but it's clearly not genetic transmission because you just can't have mating be assortative genetically at that higher level, right? People don't observe other people's genes. The things they do observe will be loosely correlated with the genes, and so the underlying correlation is going to have to be lower. And so the phenotype assortment, for example, on years of education is only typically going to be 0.4 to 0.5. When we go back to 19th century England, women have no formal education, right? It's kind of a tragic feature of the society that Oxford and Cambridge don't admit women formally until the 1920s, right? And they were allowed to take the exams, they just couldn't get a degree, right? And so they were actually entered into the exam records with an asterisk that would say where they would have scored had they taken the exam. And already by the 1860s, they had women who were in the top 10 of the mathematics tripos, but not formal admission to the university until 50 years later. It turns out, however, in 2017, this paper came out, Genetic Evidence of Assortative Mating in Humans, where, again, the phenotype correlation of years of education is 0.4. the correlation in the whole genome predictor of years of education is actually 0.65. And that turns out to be exactly the number that you would need to kind of fit with the data that we have. And it is this bizarre case where somehow people in matching with spouses are somehow detecting their kind of underlying genetics that disposes them to education, right? And the idea here would be, well, when you match, you don't just say, well, did you go to college or not? There's a whole set of personality traits and other things that bind people together, and that somehow this is a much more comprehensive inventory of people's underlying kind of educational potential. And one of the things I should say here, in some sense I would say, is this genetics or culture? The interesting question about this, though, is this is very much a cultural expression, right? The way we choose to match in marriage, and so in some sense this paper really is about a combination of genetics and culture, right? Where the question is, why do we have such a strong cultural tendency to match to people who have the same potential for social status, right? Particularly, the question is, in 19th century England, where women had no formal occupations by and large, but still you're matching, and what I'll show you is you match to people whose brothers look very much like you, right? Because we can kind of proxy their status by looking either at their fathers or their brothers. And so if I have an educated brother, I'm likely to marry a man who's also educated, right? And so that there is this correspondence. And so what we can actually do is that if you look in our data, if we look at the correlation between brothers and brothers-in-law, as I say, it's there, but for higher education, it's only something like 0.18. For wealth, 0.41. For occupation, it's pretty good. But if matching is on the genotype, then if we estimate the correlation between brothers and brothers-in-law using an IV, and using an IV, another measure of status, right? So if we estimate what's the correlation of education, but using wealth as an IV for education, then what should happen is that if they're both deriving from an underlying matching on the X's, then that random error component will be kind of knocked out, and you'll actually observe the underlying correlation of the X's. And so what we can then do is go back here and say, what happens then if we IV for wealth using occupation or using education? And what you see is that in every case, these correlations become very high, right? And so here again, if we then it jumps up again here, and then even higher education doesn't jump up quite as much, but it's still very high here, right? And in fact, these are almost too high to fit the data, because we actually were hoping to get a correlation of about 0.65, right? And so these are actually have moved up even more in some ways than we would expect. But the data is kind of saying that somehow in this matching, people are behaving as though they're matching on some deeper attribute of the other parties that's actually linked with randomness to the various components that you observe, and that there's some kind of deeper process of matching going on. And the amazing thing is that if we do this for the period before women have any formal education, the matching is just as strong, right? And so it's actually saying that it's somehow something very fundamental about these societies is this type of matching, right? So men in England in the 19th century did not match on women's attractiveness or women's just their wealth or other attributes like that. They seem to be matching on this basic kind of underlying social competence of the families that they're matching into. And so that's, as I say, very interesting. And what it actually suggests is that we don't have to fear that social mobility will somehow become slower, right? So people like Charles Murray have argued that the rise of college education for women is actually going to cause a slowdown in rates of social mobility. But as I say, the matching here is so strong already that there really isn't much opportunity for this. And so with this data, we can do other tests about whether culture or genetics really matters. For family, in the period 1780 to 1879, family size seems to have been essentially random in England. A sign of this is there's very little correlation between brothers or between children and fathers in terms of what the family size is, right? And so it just seems to have been people got married, children either appeared or they didn't appear. Sometimes there's one, sometimes there's 18. So in our sample, the largest family, completed family size, children who reached age 21 is 18 in our data, right? And so, and the question then would be, does family size play a significant role in determining people's outcomes? If resources really matter as another alternative for explaining persistence, then family size should make a big difference in terms of your outcomes. We also have birth order here. We also have this interesting feature that if we regress the outcome of children on the parents, but also include the grandparent status, that will be a significant predictor. Now that is fine within the genetic model because it's just providing more information on what the underlying genotype of the parents is. In a cultural model, the parents would have to play some causal, grandparents would have to play some causal role. So we can then divide up the sample and say, well, what about dead grandparents? How are they as predictors compared to living ones? And the answer is they are exactly as powerfully predictive. What about grandparents who live 100 miles away? They're just as predictive. What about uncles? Uncles also have doesn't matter if they're alive or dead. You could use cousins. You could use people who came after the person would also serve a predictive role. And so the interesting thing, as I say, is that you don't find any real evidence of the kind of causal role here. And then we've also considered, we haven't done much on this yet, what about, are you from a relatively isolated family? Or do you come from one with more extensive social connections, right? Does that play an impact in terms of your outcomes? But just looking at family size, in our data, by child, here's the average kind of SIBSHIP size, or here's the distribution of SIBSHIP size. And so the average for completed families is around about 7 in this period in England. And so you can see that there's enormous variation in terms of the family size that people experience. What happens, for example, to occupational status as a function of going from families of 1 to 2 or over 10? It makes essentially no difference, right? And this is for poorer lineage sons, and then this is for the lineages that were rich, right? And as I say, it makes essentially no difference in almost all of these measures. It turns out when we do this carefully, there is almost always some slight negative effect. But quantitatively, it just is very minor, right? And so we actually can detect this negative effect, right? And the puzzle here is, well, you know, once you come to 10 here, these are families where surely there's less food, there's less parental attention, there's less of all these other things. It has just surprisingly little impact in terms of outcomes here, right? And the one thing where it does have an impact is the wealth of children in richer families. But what we seem to be discovering, and here we need more data before we can be conclusive on this, is that there's a very rapid move back to your expected wealth level in the next generation. That it actually causes this temporary shock, but then your wealth is out of line with your social status, and that in the end, the wealth is actually adjusting to overall social status. If you're a family of 1, you spend like crazy. If you're a family of 10, you accumulate like crazy. And that you're moving back into this kind of equilibrium where essentially if you're a doctor, you'll have wealth that falls within a certain class. If you're a bishop, you'll have wealth that falls. If you're a nailer or a laborer, again, you will tend to have this within a certain class. So the conclusion then is going to be that differential reproductive success of different social classes will change overall economic abilities of the population. And because of this very strong linkage, it will actually change things fairly rapidly and fairly significantly, right? Because there's very strong inheritance of these characteristics because of the high degree of assortedness in mating. This could produce a rise in economic abilities in England from 1250 to 1800 in the run-up to the Industrial Revolution. But for men born from 1850 to 1929, there's a very strong reversal, so that average British economic abilities must have declined substantially. And so this presumably will be a testable implication. And just to show you what that decline looks like, what I've done here is for people where we have complete fertility, calculated the net reproduction rate, that is the number of children who reach adulthood, number of male children who reach adulthood, right? And so 1 would be just reproduction. And so 1.5 is growth in the population. And this is for people who had university or educations or the equivalent. And so what you see is that starting in the generation born in the 1830s, marrying in the 1860s, there's a very rapid decline to well below replacement rates of fertility. And then a rebound for people giving birth in the 50s and 60s, but then a decline again. But we're not so sure. We need more work on this data. I think we're missing some things here. And then for people who fall in the lowest occupational classification, who are roughly equivalent to laborers in terms of their social status, what you actually see is a persistence of more reproductive success, and then finally a kind of equality. So there's just a period here where these two really diverge substantially. But what's the consequence of that? Well, we can then calculate for a cohort, taking a cohort of people who were educated and who remained educated through this period, we can actually calculate how many males would there be in each generation down to the 1970s. And what you see is for this educated group, essentially it's static by the end of the period. And this is going from the 1790s down to here. There's a period of growth and then a period of decline. For the workers who would be in the laboring class, there's again significant growth. Eventually the decline sets in our data, at least, though I'm not confident that we're capturing this correctly. But the ratio here is roughly 5 to 1. And so this would actually, as I say, mean that there had been very significant changes. If this is right, and this is very tentative, right? But if this is right, it would say there really have been significant changes in the characteristics of the population over this time period. How significant would such effects be? My intuition, and I guess this is just an intuition, is this would have more effect on the distribution of abilities than on the mean, right? I think you'd have to kind of simulate it, but that it would have more effect in terms of what's the upper tail and the bottom tail of the distribution than on the mean. And it's actually not clear in economics what really matters for economic outcomes. Is it the mean of the distribution, or is it the distribution? Is it the tails of the distribution that really have a big influence in terms of economic outcomes? But the conclusion is going to be that the interaction of demographic patterns and social classes would have significant effects potentially on the economic capabilities of populations, and that England in particular experienced these dramatic shifts in demographic regime that would actually have some moderate, the big effect would be the pre-industrial thing because of the length of that period. The kind of the post-industrial blip would have a more limited impact. And as I say, it'd be interesting, we haven't got the data yet together to really see what's happening all the way up to the present time. Anyway, and so there's going to be a planned book based on this, and in keeping in line with the earlier books, this one will be For Whom the Bell Curve Tolls, Culture and Genetics in the History of Human Society. Thank you. Questions?
So how do we test this in terms of real life consequences over the next 20 years? Societies look very different.
Right.
England, you've illustrated very carefully, has some very quirky characteristics. What would one, you think, see if this is the case?
Well, it turns out there is an interesting case within England, right? So another thing we observe in our data, and we also have very good surname evidence on this, is that since the beginning of the Industrial Revolution, educated people have been leaving the north of England and moving south. So people of higher social status, and also the people moving south to north have been of lower social status, right? And there's been a huge sort going on in the English population. And so we can actually characterize how strong that sort is, right, in terms of some of the metrics used here. And then we know, for example, for England, we know that the probability of going to Oxford or Cambridge is about half in the north of England compared to the south. We know what output per person is. We know what life expectancy is and stuff like that. And so you could actually even just look within England and say, here would be a way of kind of parameterizing how big these effects could be on a society.
So will you reprieve the people who study single places?
So yes, I will have to. I'll have to go and talk to the single place society now, and it turns out that, I mean, with that evidence, we can actually see very clearly. We have good evidence that there is no disadvantage for. In England, you can separate surnames into northern and southern. People with northern surnames are doing just as well as people with southern surnames in England. It's just that the ones who stayed in the north are doing relatively badly, and the ones who are in the south now form an elite within southern England. And so you can actually see this process very clearly. And so, as I say, it's an interesting idea, but in some sense this would say, here you can spell out the consequences of this kind of process. The other thing that's interesting in our data is when we observe people now migrating from England abroad, in line with our recent experience with Trump, most countries where the English emigrated, they were an elite, except for America. The English moving to America are typically lower class, and interestingly, within America, they display no greater social mobility than they do within England. So if you compare them with the ones who stay in England, they're not doing any better. And so in some sense, you could say, what about if we follow the history of these different groups? Because the ones going to Australia or Canada tend to be more upper class. And so you can actually then follow them within these countries. Yeah. Yeah.
I had one quick question. What do you think, could it be that there's a sort of, so you have the decreasing family sizes, people get richer, is that, and then poor people are taking longer as we all get wealthier to catch up and then have these small family sizes again?
Yeah, that seems to be, that's what's happening. I mean, what is kind of stunning about the English upper classes in this period, around about 1890 to 1920, is just the extraordinarily low reproduction rates and low rates of marriage. And what's amazing is we can observe all of these women who have substantial amounts of money, who are unmarried in this society, right? And so you would think, I mean, these would be perfect, you know, these would be fantastic partners. You could retire, you could live a nice life, but it's a very interesting kind of movement, an unexpected movement within the society from, as I say, it takes only 20 years to go from unrestricted fertility to having extraordinarily low numbers of children. And as I say, since then there's been this rebound. We really need to go back and try and measure the data much more carefully to see what relative kind of reproductive success is within the modern period. But it is a kind of a dramatic movement. And one of the things we see is in these lineages, which are very wealthy, very few men in the end have any survivors now, right? There's a few who are very successful. But the most history of these lineages, if you're just looking at the male line, is that the thing dies out. Yeah. Sorry, go ahead first.
Okay. Very, very provocative, very interesting. I'm going to put myself in the camp that I'm a little skeptical about the assortative mating coefficient. And it's hard for me to fathom how you could generate an M of 0.6 if I understood the equation. So I want to ask you a question about that. The M of 0.6 would be a genetic correlation that would be greater than the sibling correlation, right? And
that's good.
yes.
Yeah.
So we do not,
is that right?
because we don't know each other's genotypes.
Right.
We do assort with one exception. I'll get to here in a sec.
Right.
We assort on phenotypes. So to generate, if we're assorting on phenotypes, to generate an M of 0.6, you'd have to have extraordinarily highly heritable phenotype on which mates almost perfectly match to get that 0.6.
Can I correct you on one thing?
Yeah, okay.
During the mental calculation, no, with that type of assortative mating, the sibling correlation would still be higher.
No,
that's
right.
Yeah.
But I'm just saying
Right.
in a random mating
Right.
that we overlap 50% with our
Yeah.
siblings. But the one area where we can assortatively mate on genotype is when we inbreed. That's I think the only
Right.
human example of where we actually do, at least until now, we don't know our genotypes. And I do know that the aristocracy did inbreed. To what extent do you have evidence of inbreeding in and at what level did it
Right.
exist?
Right. So that's interesting because, as I say, we have all these rare name families. We do observe then this cross-matching between families. We haven't tried to kind of systematically look at, what.
Just historically, how
Right.
much inbreeding, what was acceptable?
In terms of marriage, well, we do see, I think there's one case where someone marries their uncle in our data, and which I was surprised. I didn't think that was legally permissible in England, but yeah, you do see cousin marriages, but this is just an impression because I haven't looked at it systematically. I don't think it's that close. I honestly, I think. And I think it's a very good point, though, that we should actually systematically lay out, well, what's the degree of connection? Because we can, in the lineages then, we can actually measure for everyone how close are you connected. And then if you're not in the lineage, the trouble is we don't know then. But we can say for the ones within the lineage, we can say at least, here's how close you are. Yeah, yeah, yeah.
Okay. I think it's a false dichotomy when you talk about the mean versus the distribution and whether these trends should affect one or the other. The data seem to indicate that the mean of general intelligence is declining in Western populations. We now have polygenic scores indicating this from Iceland. New study from America, from one of the Domingue papers, shows very clear evidence the mean is decreasing. The decrease is at a rate of somewhere between 0.5 and 1 point a decade based on what sort of corrections you make for behavior genetic attenuation, that sort of thing. And if you change the mean in the distribution of these traits, you're going to have huge effects on the proportion of phenotypes at the very high accomplishment end. So in terms of the impacts of this, what you would expect to find, and what you indeed do find when you look at the literature, or look at the data, is a huge decrease in the proportion of eminent individuals, people capable of making major macro innovations or disruptive or foundational contributions to science, technology, medicine, philosophy, etc. And you see these trends very clearly in the data from multiple different converging sources, dating back to around the 1800s to the 1850s. You get this inflection point. If you go back further, you see an increase. So there's clearly this period of G going up due to these processes of downward social mobility and bootstrapping that you're describing. And then there's this upward social mobility, scare quotes, with bars being lowered. More and more people can enter into elite professions because the elite are boiling off, essentially. They're not reproducing. And then you have a situation where the mean productivity economically of the society decreases as per the macro innovation rate per capita data. So I say both are relevant.
Right.
One affects the other out of mathematical necessity, and the data are strongly supportive of this as well.
Right. When I said what I was concerned about is until you specify what the reproductive gradient is with where you are in the distribution, it seemed to me potentially the case that you could have differential effects in terms of the mean, and then also if you really have the gradient falling very steeply for people right at the top, then you could actually have very big effects on the top without having so much effect at the mean, right? And so what we've just done here is looked at kind of the bottom and the top, and so we'd have to characterize the whole distribution, right? So I just back off from that is that I'd personally, at least, I'd have to think a little bit more before I just thought, well, it doesn't matter whether we worry about the mean or we worry about the variance. And it might be the case, right, that that's exactly right, that it's just unitary, that all that matters is the mean will have the same variance all the way through, but I just have to go through and convince myself of that fact. Yep.
Hi, thank you for a really interesting talk. I wondered if you'd given any thought to how your next book's likely to be received politically, because it seems to me the political implications could cut both ways. First of all, you can imagine social Darwinists using some of your data to buttress their cause. But on the other, and I think this is a point you made when discussing The Sun Also Rises, if it's the case that low and high SES are inherited to a great extent, then that suggests they're not deserved. So you can imagine someone using that to make a moral case for more redistributive taxation. So I wondered which you thought, who do you think is more likely to leap on these findings, the right or the left?
That's a very good question. I hesitated a long time about this title. I think it's a very nice title, right? And it's very captures something. I hesitated because I thought, well, how much do I want to live in the shadows? But what I hope is that by treating the subject kind of objectively, that at least you can say, look, here's some interesting facts about the world, right? The other thing I'm hoping is that there is, after 1930, no kind of class gradient in fertility. So you can just say, this is a historical episode, it's kind of an interesting episode, but it's not the world we live in now. It's not something we have to be concerned about now, and so we can actually treat this as, there were these interesting movements within the history of the society. They caused interesting social reactions, and also, that there's lots of, the assortative mating issue is very interesting in terms of, why do people match in that way? Is there some kind of, is that a purely cultural phenomena, or is that also driven by some kind of underlying biology? So yes, so I am still hesitant, and I'm old enough that I think, what do I have to lose? That sounds exactly like Trump, right? What do you have to lose? Vote for me. So that still has to be done in some senses to say, well, because a lot of these themes are in The Sun Also Rises, and that didn't provoke a firestorm, right? And I think if you just, if you stick to kind of relatively objective kind of facts about the world, then these are interesting issues about the social world that we live in, and that they deserve to be kind of discussed.
Can you draw any conclusions from the fact it's very difficult to design a test of the cultural hypothesis? Everyone seems to struggle with it. We pass money on, and that's privilege. Should we just track the money and?
Right. No, it is a good point that it would be intellectually much easier if there was a very specific kind of cultural hypothesis, right? And so I found with the early work, when I find this kind of very strong underlying correlation, that some people just dismissively say, oh, that's all family networks, culture, stuff like that. And it's just very easy. But there's no content to that statement, and it's just amazing how easily you can just throw that in and assume that in some sense you haven't said anything, right? And so that's why, as I say, it would be nice, but when you think about these cultural models, as I say, I think you're capturing something of the essence with this model here, but I can still exactly imagine that people will say, this is the product of family networks. And I actually have wrote another paper where I try to show that with a cultural transmission mechanism, so suppose you imagine, so the Jewish population shows the same slow regression to the mean. And that, some people might argue, is because of a particular cultural heritage within that population. It turns out that that would affect the dynamics of your movement towards the mean, because you would regress towards your cultural mean, and then that cultural mean is regressing, and it will actually produce a dynamics. And I have another paper where I show that the dynamics we observe with these families is there's always one period of rapid regression to the mean, and then you move to that long-run slow regression to the mean. And that's not compatible with an idea of you being influenced both by kind of family and also by culture, right? It would produce a different path. And so I think we can make some progress because we can at least specify some models and say, well, you can rule out, group cultures. You can rule out, that it's all just family environment. So the idea of the book would be to develop a nice kind of repertoire of these kind of interesting tests of one model as opposed to the other.
Seems to to have exhausted the questions. I can't help but look at the motto here of the Society, knowledge made useful. It seems just about perfect in terms of useful knowledge. I hope you've all been hearing. If we could thank our speaker.